Welcome to the Transport Leaders Podcast, where we discuss the breakthrough ideas and bold solutions transforming the future of transport around the world. Join a global community of transport leaders, professionals, academics, and advocates as we unpack transport's toughest challenges and spotlight the strategies driving real change. From system reform levers and political realities to sustainability and technological disruption, experienced transport professionals, Graham McCabe and Russell King and their guests offer expert perspectives as we discuss ways to transform our transport systems.
G'day, I'm Graham McCabe. I'm founder of Step Advisory, a transport planning and traffic engineering firm, and I've worked in consultancy and government for over 25 years across Australasia and Asia. Okay, Russell, what are we going to talk about today?
Today, Graham, we're going to talk about electrification. We're not going to talk about electric vehicles per se, which is obviously a big topic, and we'll do that on another podcast. But let's talk about electrification of transport generically.
Okay, all right. So electrification. So obviously transforming from using primarily fossil fuels into electric motive sources. What do you want to talk about in that area? Should we give people a rundown of?
Yeah, let's start from the first principles. Why the hell do we want to do electrification in the first place? What is this thing, electrification?
Okay, all right. Well,
sounds, big word. What is it? What are we talking about here? Why are we doing it?
All right, so it's using electricity for transport. So, and we've been doing that for a long time. So we've been, if you think about railways, the first electric railways were in the late 1800s, and electric tramways, but even trucks and cars. So the thing that killed horses as a means of transport in New York was electrification, not the internal combustion engine. So in the early 1900s, electric goods trucks displaced horses in large cities around the world.
Yeah. So why are we talking about something that's a couple of 100 years old as a technology? What's going on here? Is transport going backwards? Why the push now?
So the technology of the internal combustion engine, particularly diesel, for freight and passenger movements, leapt over the available battery storage capabilities. So the batteries in the early 1900s were lead acid, so they're very, very heavy, like the 12-volt battery in most cars. Very, very heavy, don't carry a lot of charge, don't provide a lot of power, so you can only do short distances with them. Internal combustion engine, you have a very small amount of, it's basically an explosive, and you do lots of very small explosions, and you use that to drive a crankshaft, which then turns the wheel. So we went from having a clean but inefficient system to a dirty but efficient system, and now we're going back to having a clean and efficient system because the type of battery technology has changed. And the technology for electric motion via contact with cables in trains, trams, trolley buses, etc., basically hasn't changed. It's the same thing. We've gone from DC to AC, higher voltages, but most of that's still fundamentally the same at a basic level.
So the battery technology stuff, that applies to motor vehicles. But as you said, trams and railway, they don't typically have batteries on them, or if they do, it's for very short distances between access to the electric grid, isn't it? So what's changed there? What's why, we've been doing electrification for railways and tramways, as you say, for a long time, but there's still a push for electrification of trains, and we've still got lots of trains that are not electrified. So why electrify these ones now? What's been holding them?
So So using electricity has a higher capital cost, but the operational costs over the life of a system are so substantially better that if you can electrify a railway line, and you're using it frequently, then it makes sense. And it's also about, who's paying for what when. So a truck moving a container of freight, they know how much fuel they're roughly going to use, and they can amortize that into the cost of the carrying of the cargo. And the freight truck industry has about between 2 and 4% profit margin on it. So investing in electrification is quite expensive. So you take that all of those costs and the ability to pass them on, and you put that on top of a railway. And if it's not a government-run railway, then somebody has to pay for those costs. And it's operationally easier to charge somebody an amount of money to move a container based on a much lower upfront capital cost, but a slightly higher operational cost.
Yeah, you've got there's a financing thing element in this space, which is one of the dynamics. But there's advantages from electrification that go beyond just slightly lower operating costs, right? In the railway space. Yes.
Yeah. Well, so there's efficiency, there's decarbonisation, there's noise, but a lot of locomotives are what's called diesel electric. So they're what people call a pure hybrid in motor vehicles. So the diesel engine is actually acting as a generator, and the motive in locomotive is actually coming from an electric drivetrain.
Okay.
And we've had those for decades as well.
Yeah. Now, are those drivetrains? Because I think one of the advantages that people talk about in electrification of trains is that the trains are quicker. They accelerate faster, and they've got higher top speeds typically, given the same amount of keeping everything else constant. I understand. Is that correct?
Yes. Yeah. So when you look at energy input versus energy delivered into motion and performance, then electricity is a hands down winner. So to give a trucking example, there's been a couple of trials where they can take a 52-ton, that's metric ton, B double, so 2 trailers, total length 29 meters, up a 12% grade at 75 kilometers an hour. You can't do that with a diesel engine. A diesel engine will probably be going along at their crawl speed of about 25 kilometers an hour, because the difference in the amount of torque that you can get from electric motion. So the torque is what gives you the higher acceleration. And anybody who's had a electric car overtake them knows that they're actually a lot of fun to drive. But yeah,
as long as you stay within the speed limit, I just hasten to add that.
I never speed. Background in road safety engineering.
Yes, I think that's true of a lot of road safety engineers. I think they have. I'd love to see some research on the general public versus road safety engineers in terms of their driving behaviours. I think it would be quite revealing.
Yeah, I can. Yeah, I can have fun, but still be safe. I'll put it that way.
Yeah.
Using
okay.
Yeah, because the other thing is that they also use the electric motors to brake as well. So you can have fast acceleration and fast deceleration on electric trains, electric trucks, electric cars. So as there's more and more electric trucks, people will be surprised about the capability of the trucks, what they can do. They can accelerate, particularly if they don't have a load, the same as a car.
Yeah. So in terms of rail, just trying to, without going into deep dive into rail, so you're looking at it's lower operating costs. You've got, higher top speeds and better acceleration. You've also got the decarbonisation angle. So this is assuming that your electricity source is at least less fossil intensive than the diesel that it's replacing.
Even if it's from brown coal, it's still cleaner.
Ah, okay, that's interesting.
Yeah.
So even if you've got a dirty fuel source for your electricity, it's still cleaner than running a diesel engine.
Yes.
I did not know that. That's a very interesting. That's a very interesting thing as well. Okay, so you got lots of advantages there, and one of the things I know that is an issue on the electrification around rail is how you go about doing it makes a significant difference to the costs of electrification.
Mm-hmm.
So one of the things I've seen is jurisdictions that have had a strategic program of electrification, i.e., we're going to electrify huge amounts of our network over the next decade. Okay, and here's the funding certainty for that decade. Okay, versus, I think, which has been a more piecemeal model in some jurisdictions, where it's been, let's put up a business case to convert this bit of track into electrifying this piece of track. And my understanding is what happens is if you've got that 10-year sort of pipeline certainty, the entire industry invests, right? They invest in skill sets, they invest in technology, in equipment, okay? And what that does is it drives down the cost of electrification per kilometre. Whereas...
Which is something that we're seeing across the entire industry sector that we work in, is when you have a long-term program rather than piecemeal projects, it drives down costs. Absolutely.
And that's true in metro, whether you're doing a metro, a series of metro projects, or high-speed rail projects. If you have a pipeline of the similar types of projects, people's learning curve, they got the learning curve, they invest in the technologies, they invest in their people, because there's a long-term return, right? And then what happens is the cost per, whatever your unit is, cost per kilometre or operating cost dramatically drops over time. And so we're kind of struggling with the electrification in rail on some jurisdictions because they can't seem to get together to do a program of electrification. What's your read on why that doesn't happen? Why do some jurisdictions take that long-term sort of 10-year view, and other jurisdictions it's like, every 2-bit piece of line they want to electrify, they have to put up an expensive business case, and it's stop start all the way through the process?
Well, so I think this comes down to just the regular, policy project framework. If you don't have the policy and you don't have the reason, then you end up doing piecemeal projects. Like Victoria.
This is Victoria in Australia,
So around Melbourne, they are very incrementally extending their electric rail network as the urban fringe of Melbourne grows. But when about a decade ago, they built a diversion railway line that takes people from Melbourne to Geelong, which is their second largest city, which is about an hour's train trip away. But line had previously run on a mix of electrified and unelectrified lines, but the whole service was provided by diesel trains. But they wanted to use the same trains as they're using for the rest of the regional network. So they built a brand new line on Melbourne's Western Urban Fringe and only made it diesel, saying, oh, well, we'll electrify it at some point in the future. So, and now this urban fringe, the growth in residential areas is meeting that boundary. And they don't have enough trains, and they don't have enough capacity to provide the services. So they're going to have to make a choice to integrate it into their, what they call metro, but it's suburban trains, what Americans call regional trains, so that they can actually provide the capacity for all this housing that's appeared, or they'll have to electrify their line to Geelong. But now there's a move to go back to the previous alignment because nominally it was 10 minutes faster. So they're going to provide additional tracks, but they still haven't decided what they're going to do about electrification. It'll be electrified at some point in the future. And that's very typical of the Australian approach. So the only two, Perth and Adelaide made decisions in the early 2000s to start heavily electrifying their networks, but even Adelaide stopped doing that and is now doing hybrid trains and claiming that they're great.
Are the hybrid trains more green than a diesel train? I assume they are.
They are, yes, more green, but you have
less green than a fully electric train, presumably.
You have the doubly complex issue of you've got two systems that need to be maintained.
Yeah, it's higher operating cost as well, right? Because hybrid is,
yeah,
it's not really a hybrid. It's not half and half, is it? It's 1 + 1 is 2. You kind of more like.
Yes. Yeah. Yes, and that was the experience that London had with its buses. Is they went to so that they played around with hydrogen for a tiny little bit, like Perth did. Unfortunately, New South Wales is doing the same at the moment, and all that hydrogen comes from fossil gas. None of it's clean. So when London did their hybrid buses, they were pure hybrids. So they were diesel. They were really small capacity diesel engines, so about 1.5 litres. So if you think about 1.5 litres of engine compression chambers, very, very small for a bus.
Carrying potentially up to what, 80, 90 passengers. Yeah. So that's very definitely more efficient than a pure diesel bus, because you only run the generator when you actually need to charge the battery. But now the cost of batteries, the energy density of batteries is now at the point where you just buy electric. No regular bus route is going to be needing a hybrid engine anymore. Yeah. So I just want to finish our point on why some jurisdictions, Victoria being an example, are struggling with electrification on rail. So there's a kind of, one is, have you got your policy and your strategy set, first of all? And then the Adelaide example shows you've then got to be consistent about your policy and your strategy. So you don't want to be changing every time there's a change of minister or, right? And the other thing on this, I also think is relevant is the policies that the Treasury Department uses and the incentives that the Treasury Department provide. So I think that treasuries like to have lots of short-term control over budgets, i.e., say over the 3-year forward estimates. But what that does is it means they don't provide certainty on funding over, say, the next decade, which you get in those jurisdictions that really drive down the costs. And so what you end up with is there isn't the incentives, I think, in the transport space for depending on the Treasury Department, for talking about long-term program investments, because you have to keep going back. They won't accept a kind of business case over the next 10 years kind of thing.
Yeah. Well, and it's also the capital versus operations issue. You know, if you want to reduce service with a diesel-based system, it's actually easier to do because you just don't run the vehicle, so you're not buying diesel anymore. Whereas with an electricity-based system, you still have all the maintenance of the electricity infrastructure on top of whatever other infrastructure that they're using, whether it's roads for buses or tracks, signals, etc. for trains. So it's that ongoing long-term operational cost. And then there's also, other decisions like privatization. So New South Wales used to have, Greater Sydney used to have a lot of electric locomotives. And ironically, all the coal that was being exported to be burnt overseas was being moved by, a lot of it was being moved by electric train. And then they made a decision to privatize that part of the rail fleet. And the new operators had no interest in maintaining or contributing to the maintenance of that electricity system. So you have the instances where they had started putting up stanchions to hold the catenary wire, and then they stopped running electric locomotives, and so there's all these, quite expensive metal poles out in the environment.
I think that's a very good example of where the left-hand policy arm is not talking to the right-hand policy arm and making sure they're nicely aligned in what they're trying to achieve, which unfortunately in the transport space happens a lot. And
there are decarbonisation alternatives to electrification. So hydrogen is one of them, which has a very low, it's called round trip. So basically, how do you create the hydrogen? So how do you use it and the efficiency throughout the process? And you use about 2/3 of the energy that's expended in creating and using the hydrogen either in hydrogen combustion or in fuel cells is not put to the motive power. So if you're making green hydrogen, you have to go through electrolysis to create the hydrogen in the first place, which is exceedingly inefficient. Then obviously you have to store and transport it the same way you store or transport any other fuel, and then you use it in the end vehicle. And it's there's a target of $2 a kilo, which would make hydrogen economically viable for transport, and we're currently sitting at about $10 a kilo. So without massive government subsidies, it doesn't work. And there's been a lot of hydrogen train, truck and bus trials around the world, and most of them have failed.
So I don't disagree with any of what you said, but there are some people who really believe big time in hydrogen. So what are the advocates saying? Why are they convinced by hydrogen as a solution?
So one of the big ones is range, in that you can, with a hydrogen tank, you can go further than you can go with a battery. Now that differential is becoming significantly lower, and then there's the access to grids or storage to charge an electric vehicle, and then there's some more unusual ones like Fortescue Metals, so one of Australia's largest iron ore miners, and very heavily invested in green technology they're pushing, which is using ammonia for a way to transport the hydrogen more easily, although it's not, it's quite toxic and dangerous, to then convert it into fuel to then burn it. So it's very much around range and ability to store are the two big selling points.
I assume there's a weight thing here as well, because batteries are quite heavy, right? Is it lighter? I mean, hydrogen's a very light gas, but does when you add the cell infrastructure around it, does it become a lot lighter?
Yeah.
And the reason I raise it is when you're looking at, say, for example, road damage with freight trucks, right? It's already significant, and they're about to get heavier as we electrify them, right?
Yeah.
So are we going to see a significant? Is that one of the big advantages? I appreciate it might not be an advantage for the operator. They may go, I don't pay for the roads. I don't get road user charge based on my weight. So why do I care? But if you're a government agency or a road operator, road company, it makes a massive difference if those vehicles are heavier, doesn't it?
It does it at the top end. So hydrogen's fuel container is exceedingly heavy because the hydrogen has to be kept at very high pressure. So even when it's empty, it's still heavy. So I don't have the numbers, and the hydrogen advocates are going to absolutely smash me in the comments about this.
Please feel free to do that as long as you subscribe.
Yes. All engagement's good engagement.
That's right. And because you've had the chance to comment, please give us 5 stars.
So, and you don't actually get that much range per pressure vessel. So the use case, like the best use case is supposedly very long distance where you don't have the ability to stop to recharge, or very, very heavy masses. So you would think, well, hydrogen trains would be sensible because you can just add a trailer of hydrogen canisters, but that isn't really what's happening, and there's not much investment in it. So but in terms of going back to the road damage, so pavement damage is a power formula. So at the low end, so an empty truck with batteries, the additional damage to the pavement is minimal. But at the top end, so if you currently have a 52-ton truck, and that becomes 54 tons because you allow the same mass of cargo to be carried in a truck that's been swapped to batteries, then your damage to the pavement just doesn't go up proportionally. It goes up by a power scale. So it's at the top end that the damage becomes so much. So when people say, "Oh, electric cars are going to damage the pavement," it's like, no, they are not going to damage the pavement, because you would say the same thing about a 2.5-ton ute.
Yeah.
And 2.5 ton utes have got all their own problems, but pavement damage isn't one of them.
Okay, so let me be provocative then with hydrogen. Okay, is hydrogen, project out another 100 years, could hydrogen be like battery electric is now? Okay, in that they chose originally ICEs because there were advantages for ICEs. Okay, but because and as you said earlier, partly because the battery technology wasn't good enough. It's possible that they find, in the same way that there were niche uses of electric vehicles for many days, all the way through when ICE's dominance, there will be niche uses, I suspect, of hydrogen, which will help it to improve things like, supply chain, transport. The technology will get better. It may not get sort of the level of investment that batteries are getting at the moment, but over the next few decades, you could see a scenario where hydrogen continually gets better, costs come down. Could we be in a scenario where in 50 years' time people will be going, well, we did electrification, but actually now hydrogen is the better answer? Is that a possible scenario?
So you still have to get over the efficiency thing. So the best, or you have to find wild hydrogen. So apparently, they're finding hydrogen stores in the ground, which is actually the great white hope of the hydrogen industry at the moment.
Okay.
But there's better uses for hydrogen. So there's all these other things that need to be decarbonized that are energy intensive. So if you follow the money, steel needs to be decarbonized. And the best way to do that is through hydrogen.
So things where at the moment we're using fossil fuels to do the job, and electrification doesn't do it well or can't do it at all.
Yeah.
Steel mills being a good example. And hydrogen is something that potentially is the answer for them.
Yeah. Yes. Yeah. So ammonium nitrate fertilizer.
Yeah.
Most of that is made from fossil gas at the moment. So if we get cheap green hydrogen, that's where it should go. So first, then if we get really, really cheap green hydrogen in the future. But the other thing is they might just lose their opportunity, because I do 87%, I know, because I've been tracking this for 4 years now. 87% of my charging is done at home.
Yeah.
And about 20% is from just purely my solar panels. And then the rest is cheap green electricity. So, I pay basically nothing for charging my electric car. So why would I, when 40 years time, when I buy my last ever car, if my self-driving car, because I probably won't be driving myself at that point.
Well, you raise an interesting point there, right? In that the market dynamics may completely change.
Yeah.
And maybe hydrogen will make sense for future, autonomous vehicle operators. I have no idea, but I think it's just worth asking the question. And as you say, it may be that in the next few decades, what we do is we find other uses and better uses for hydrogen in terms of its level of development now.
Yeah.
Right. But what that does is it opens a gateway for hydrogen a few decades down the road, assuming that, it could be like a VHS versus Betamax kind of scenario for those of us that are old enough to remember video VCRs.
Was a better quality.
Betamax was the better technology in terms of a pure technology perspective, but it wasn't the one that was chosen. VHS became, ubiquitous for various reasons. So I think it's it'll be one to watch. I think hydrogen, not today, not tomorrow, but a few decades down the line, I can see when I'm picking up my great-grandchildren and bouncing them on my knee, which is probably around a 60 years time, then maybe there'll be a different discussion to be had on hydrogen, and we'll have to do another podcast on it. We'll make that emergency podcast.
110, mate. That's going to be a pretty good innings.
Well, that's what I'm planning for. I'm planning for the Centurion Olympics, right? That's kind of where I'm looking at. There's lots of things that could strike you down, but that's true at 50 as it is at 70. All right. So
So and there are other fuels. So there's biodiesel. Biodiesel in its most simplest form is cooking oil. So you can use cooking oil to run a diesel engine.
Yeah.
You probably want to clean it first.
Clean the engine or the oil?
Well, probably both.
Yes.
But a diesel engine is a very simple piece of technology. You compress the diesel.
The 21st century man. I don't think if you said this to a 17th century man that they would be agreeing with this. They'd be going, "This is magic."
Yeah. No, but it is. It is magic. You take the fuel and you compress it really, really, really hard, and it explodes. Yeah. And you contain the explosion, and then you use it to drive.
If they had called them internal explosion engines as opposed to internal combustion engines, okay,
might not have done so well.
Yeah. Not done so well. There's a good bit of branding there, because like combustion, probably the average Joe didn't know what combustion was.
Yeah.
All right. But they would have known what an explosion was. But like for its day, it was a very, very impressive bit of technology, as are all of these things, right? At the time when they, my kids just think of the internet as like second nature, whereas I remember before the World Wide Web existed. So
yeah, I literally can remember the first time I typed in www into the computer. So
me too. I was 18 years old. I can remember where I did it at university. Yes. So it was one of those. It was one of those things. I didn't know how much it would change the world at that time. I was not that visionary, but I knew it was something interesting.
Yes. So back to topic. So biodiesel is a transition opportunity. So long as it doesn't become like the ethanol boondoggle. So
explain the ethanol boondoggle. I think I know what you mean.
Okay, so the ethanol boondoggle particularly came out of the corn farmers in Midwest USA, mandating ethanol into fuels. And in Australia, it was a little bit of the wheat and sugar people doing that. So yeah, ethanol reduces the requirement, the amount of petrol you need to fuel the vehicle at its most basic level. So you have ethanol blends, and you can go all the way up to the 80% blends in Brazil. So 80% ethanol, 20% petrol and gas for Canadians and Americans. And that generally comes from wheat, corn, or sugar cane. And it became a way to subsidize farmers by mandating that ethanol was included in fuel. So it does have a good environmental benefit, but then you get the perverse outcome of people growing crops just to generate income through ethanol mandate. So it became untied from the demand for the crop that they were growing.
Yes, and it does make crops more expensive because you're using limited amount of farmland for growing something that's not going into the food supply.
Yes, yeah. So you can, so you can do biodiesel and potentially the emerging product of sustainable aviation fuels from chaff, so from a lot of parts of the world, the parts of the crop that can't be used for food for either human or animals are burnt. So you can actually collect that and turn it into sustainable fuels. So it's only using, carbon that's captured from the current climate, not carbon that's captured from 60 million years ago. So it's has a much lower carbon intensivity to it, because it's only, if you're running all your farm equipment off your solar, which is something that's actually going to become a lot more common. There's a lot of heavy machinery now that's being run by batteries, and it's increasingly moving into the agricultural sector, because if you can just put a big set of solar cells and a battery up in your paddock, you're not having to import, bring in tanks of diesel to run your farm equipment. That's a massive long-term saving for a farmer.
Yeah. All right.
Yeah.
Are there any other alternative fuels that you want to cover?
No, so that's the big one. So the crops that you grow, provide and convert into fuel, they have a interim reusing current machinery and technology potential benefit, while the low hanging fruit is transition. So there's a lot of focus on doing small but hard things at the moment, rather than doing big easy things, which is where we get to cars and bikes.
Yeah, let's pause on those. Let's talk about aeroplanes.
Yeah.
Okay.
Yeah.
So aeroplanes, vast majority of aeroplanes, specific aviation fuel, right? Very carbon intensive. Aviation is one of the biggest areas of transport in terms of carbon emissions.
It's carbon emission intensity.
Yeah.
So avgas is better than most of the other fuels. It's just where it's released.
Yeah.
Which is up in the higher atmosphere.
So that makes a difference in terms of its
that makes yeah, that's
impact.
The big thing. Yes. Yeah.
Okay. So the strategies for aviation then are, at the lower end, i.e. smaller planes, is looking at more batteries for smaller planes. Is that right? I mean, we're talking about with shorter trips, sort of 1 or 2 hours, a dozen passengers, that type of thing.
They're getting up to 100 passengers now.
Okay, so potentially you could go, say, Sydney to Canberra.
Yes. Yeah, regional flights are.
Yeah, so Sydney to Canberra is about 45 minutes.
Where the technology is at the moment. Yeah. Regional flights where you're not needing to travel at 800 kilometers an hour ground speed.
Okay, and so for them then, presumably, I don't know how good the charging is, but presumably they just need the charging infrastructure at the airports for rapid charging at while they're unloading and then loading passengers again. Yeah. So that works at the lower end, but it doesn't scale very easily, partly because of the technology, right, of batteries in terms of the weight. Weight is a big factor, isn't it, in this? In aviation, weight matters, which is why we get charged so much for excessive baggage and those sorts of things.
I know you charge so much for excessive baggage because your baggage is competing with belly freight.
Oh, I see what you mean. Okay, yes.
Yeah. So this, so
when you said belly freight, I thought you were talking about. I thought you might be talking about people who are overweight that you can't actually charge extra for, but clearly not.
No, sorry, freight that is being carried in the underbelly of the aircraft.
Okay, cool. That's good.
So that is much more profitable because that's high value, short travel time requirements, like, you know, fresh meat and
Fish and those sorts of things, yeah.
jewelry or whatever, that's, you know, being carried around the world. So your bag, which has no value to the airline, is competing for kilograms of available carrying capacity in the belly of the aircraft. So yeah, that can also get away with it.
They can.
Because what are you going to do?
Yes, it's a good thing. So
yes.
Our conversation on energy, right? So batteries, as you say, we've got up to sort of smaller planes, smaller sort of regional trips. I think there's a lot of people that I don't think the strategy that I've seen for 2050 for the aviation sector around the world is we'll make, you know, batteries will deliver the answer that we're looking for in aviation. So the vast majority of the strategies are around what they call SAF, sustainable aviation fuels.
Yes, it is. Yeah. And there's a big challenge in that at the moment is people. So there are people who are looking at how to actually create the fuels at large scale, including the large fuel companies. But there's no. So the funding is the problem at the moment, that people won't fund the projects without commitments from the aviation industry, and the aviation industry is not going to act without a requirement from government.
Yes.
So the aviation industry has signed up to net zero by 2050.
Yeah, it's not the enforcement mechanisms to deliver on it, I think it's fair to say. And as a consequence, you haven't got the investment certainty, so people aren't investing in the sustainable aviation fuel through the private sector. Therefore, you're left with the public sector picking up the bill because nobody wants to force the aviation sector into doing it.
And the engines aren't ready. So there's been quite a lot of flights with mixed fuels, and mixed SAF plus avgas has been type approved in some existing aeroplanes. But for ones that run purely on SAF, there's no currently approved planes.
Okay. So as with all these things, there's a whole bunch of challenges. It's not just a question of producing the fuel. You then got to distribute the fuel. You've got to actually use the fuel, and it has implications. It's not just simply a straight replacement for what's already being used. So, okay. So that's kind of planes.
Yeah.
Before we get on to cars, which is obviously a big thing, and don't go deep into it because I think we can do electric cars to in a bigger piece, because I think there's a whole bunch of other stuff in electric cars other than just electrification. One of the things I think is interesting is motorcycles. So I've seen recently I've seen two schools of thoughts on motorcycles. One was that motorcyclists, the nature of motorcyclists and what they like about motorcycles, couldn't be replaced in terms of the experience through electrification. So going from current motorcycle engines, internal combustion engine motorcycles to electric motorcycles. But then I saw something quite recently, which was someone claiming that there was an electric motorcycle now that actually was, if anything, better than the experience of an internal combustion engine on motorcycles. My impression at the moment is motorcycles, because they're a relatively small share of the mode, there hasn't been a lot of focus on electrification of motorcycles, but it's one of those things that sort of is catching up with them. So they haven't had a kind of Tesla moment, if you like.
Yeah. So there are a lot of electric motorcycle brands, and when you get into scooters, there's even more. Like electric scooters are really big success in places like Taiwan and India. So where you already have high scooter usage and people move across them. But yeah, in the motorcycling world, I'd say that there's two schools of thought. There's the people who like the vibration and noise, my views on motorcycling will come out very quickly, and annoying everybody else in the world. And then
so let's think. So far today, people who like hydrogen, they hate you, and now motorcyclists too. Okay.
Yeah.
But have you asked anyone else today? And Graham, you're doing very well.
So that's one group, and we all know which brand they buy. And then there's the other ones who, like being in the outdoors, like being close to, the environment, understanding intimately the road that they're riding on. And they're the ones who seem to be more aligned to electric motorcycling, because they can actually hear the world around them.
Because it's much quieter.
Yeah, so they get all that enjoyment from the motorcycling. So if you're a motorcyclist whose enjoyment comes from the act of riding the motorbike, not being part of a tribe where you go around vibrating your way around the world, then an electric motorcycle would be a fantastic thing. But they still don't have the range, because it is a weight and density thing. So you can't you can get electric cars with, if you want to pay the money, you can get an electric car with 1,000 kilometers range on it now. But you can't get an electric motorcycle which has the same range as a petrol motorcycle.
Yeah. Okay. So we touched on motorcycles. Obviously, there's a big push around electrification of cars, and we should do a whole separate podcast on electric, because there's a whole bunch of different things in there, as I said before. But the thing with all of these things is, predominantly because of net zero, although a lot of these things have other benefits, it's predominantly because of net zero that there's a push to decarbonize the transportation system and electrify or use alternative fuels that are much less carbon intensive. So if you're a government, okay, and you have a whole range of potential investments to decarbonize and electrify, what should you think about? How do you think we should be prioritizing those investments?
Yeah. Okay. So I'll talk from the technical perspective, and then you can talk from the political one. Okay.
Yes.
So if I was given the task of prioritizing, I'd look at number of people affected or benefited. So, and that could be in environmental health improvements, reduction in emissions, vehicle kilometers traveled, ton kilometers moved. So how what's the fuel, the carbon intensity of those activities? So and then obviously you've got the distributional and equity effects. I could afford to get solar and electric cars, and government subsidies were enabled the tipping point.
Nice little subsidies there. Yes.
Yeah. But what that did is it moved to modern fuel efficient cars into the second-hand market. So while
I don't want to get into like there's a whole bunch of secondary effects that it had.
Yes, yeah, right? but that's but those things are important. So that's why
they are, and then you have to do the proper evaluation, right? You need to be doing the proper evaluation. That's the key thing here, right? Is your analysis should be taking into all these things into account in terms of is this a worthwhile investment or not? I mean, it's absolutely right. You're right to point it out. Yeah. Go on. I was just being flippant. Sorry, go on.
Yeah. Okay. Yeah. So the carbon intensity of the travel, and is it substitutable with electrification? So while we're not focusing on cars today, to say to the communities of Australia, Canada, US, that we shouldn't be subsidizing electric cars and the electrification ignores the fact that those communities are currently heavily dependent on cars because of the type of communities that we've built. So if you say, okay, well, we'll give everybody an electric bike. Right. So you could give everybody in Australia an electric bike. Good chunk of them can't use them. Another good chunk of them won't use them on the current street and road system that we have. And then if they live in suburbia where it's not financially feasible to have a good public transport system, when you're competing against all the other things that governments have to spend, do we just say to them, okay, well, you just keep emitting carbon dioxide or stop traveling? Or do we say, actually, we'll create a market for electric cars to drive down the cost of them? So now in Australia, you can buy an electric car with 400 kilometres range cheaper than the equivalent internal combustion engine car.
Yeah. So I think the key thing I would say is what you want to be doing is evaluating what is going to get you your best outcome in terms of reduced carbon emissions, primarily. But there's also lots of other benefits as well from potential other policies, right? So mode shift being a big one, okay? And although we're not expecting everyone to get on an e-bike, appreciate that not everybody will get on a bike, right? You don't want to be in a situation where you're undermining the mode shift, do you? And one of the challenges with electric vehicles, you know, has been the evidence coming out of places like Norway, where something like 90% of new vehicles are now electric. Purchased, is that they have seen induced demand from electric vehicles because they're cheaper to operate.
Yes. Yeah, they are. I mean,
so you have that. So you have that problem, right? Which is why you kind of need a more comprehensive strategy than just we'll make electric cars cheaper and everything will be fine. It's a more complex picture.
Yeah. And that's lived experience. We've talked about, the fact that I live in a regional city. I have choices, like, I can drive to the local railway station and pay an amount to travel to Sydney, or I can drive closer to Sydney and travel and pay less. Well, yeah, aside from the almost zero maintenance cost. So electricity cost is basically zero. The only wear and tear costs that I have on my vehicle are tires, and everything else is a sunk cost. And if I'm not paying a toll or a road user charge, then my incentive, given that the travel times are relatively the same, is to drive closer to Sydney. And, you know, being the, you know, economic rationalist that I am, that's what I do. So I follow the economic incentive at the moment. So, yeah, yes, we do have to address all those other things, but there is the objective of driving down transport emissions very substantially, and trucks will be a commercial imperative. We've now already got prime movers for sale, so the tractor trailer, the tractor part of a tractor trailer for North Americans, that have a lower capital cost than the equivalent diesel truck, with 600 kilometre plus range on them, which is more than a driver can drive without taking a break legally in Australia anyway. So the commercial incentives will drive truck electrification, and there are new companies which are starting up that will be purely electric trucks. In Perth, Western Australia, there's a freight company there that's electrified its entire depot, gone off grid, and is using a biodiesel backup generator. So they're gone 100% green, and their total cost of operation, even with the trucks that they purchased a year ago, will be lower than the equivalent diesel operators. So they will start increasingly winning more and more work because they will be doing better commercially. And they did have a big government subsidy to get set up to help bridge that capital cost gap. So the actual hard one is going to be cars, because a car's a personal item. A lot of people have a kinship with their car, and they keep their car for, you know, quite a while, with the average age of cars being 10 to 11 years. And most cars making it to into the 20-year mark before they end up at the wreckers. So to get to 2050, we need to stop buying electric cars pretty much now. The internal combustion engine cars pretty much now, and move.
Sorry.
Yeah.
I'm having all sorts of problems with my camera.
Yeah, that's okay. As long as it's recording at your end.
It's not recording at my end. You know that.
Oh, the camo. No,
Yeah.
I mean, sorry, I mean Google. So long as Google's recording your end.
Yeah, I think it will be recording. I think it's just for some reason my camera has been struggling.
Yeah.
Let's see if it's switched. For some reason, it's not switching on. Turn on camera. Right. Oh, there we go. I'm back on. All right.
Okay. All right.
All right.
That's all.
Okay. All right. Okay. Just before we restart, how are we going to finish this up? Because I think we're at time, and we kind of need to finish off. What do we want to finish with? What do you think we should just? I don't think we're going to have time to talk about the politics of electrification. Unless we strip out something else. We could strip out motorcycles or something like that if we wanted to.
No, I think we should do politics, because we've done how we should prioritize and kind of when not to.
All right, talk to me. Let me do the politics then.
Yeah. Okay. All right.
All right. Let's talk about the politics of electrification. And I think it's fair to say that in most cases, the political, the sort of technical analysis is playing second fiddle to the politics here. Right? So if you look around the world, I think that the policies that have aligned politically in this space may or may not be the best in terms of reducing carbon emissions, but they are the ones that are politically salient. So subsidies for electric vehicles have tended to be popular. And similarly, announcements or funding for new electric vehicle infrastructure tend to be popular.
Yeah, well, if you want ordinary people to use electric vehicles, then you need to have visible chargers.
Absolutely, and they're very and government funding for them is very popular. And I think the evidence is showing that the actual, in terms of returns on investment, charging infrastructure seems to be better than electric vehicle subsidies. And that may be because the electric vehicles have reached a price point where, as you say, they're competitive with their ICE equivalents in quite a few markets now, segments. So you've then got, one of the things I think is also when it comes to buses, announcements of buses being electrified is very popular. And we've talked previously about that's not necessarily a good thing. And that the electrification of our buses has been, certainly in Australia, in an Australian context, very slow, not well done. And it's clear, I think, increasingly I'm hearing opposition from an operations perspective that says the pain that electric buses are causing in terms of the transition are more than it's worth. And we'd be better off focusing on other aspects of the bus services. But that's irrelevant because announcing electrification of buses is, although it's small beer in terms of carbon reductions, is very popular. And then you've got rail. And I have to say, I think rail electrification in terms of politics is, is very, very small dividends. You get very little return for a very big expense. And so I think
that's really an interesting one, because you do get those promises around electrification, and then it runs into the practical difficulties of actually doing it, and the benefits. I mean, in the scheme of things, rail transport, even when diesel, is very, very low carbon intensity.
Yes. But we've gone, so I mean that's an interesting one. So do you think that the business case for electrification of rail is weak in comparison to the electrification of the car fleet, for example, and the equivalent benefit that you get?
Yeah, so if you have an existing electric railway line, I think extending it makes sense, because then you can reduce the number and types of vehicles that you're using. Whereas going from complete diesel to complete electric, I mean, it's still cheaper in the long term, but the outcomes in terms of comfort and quality of the service, reduced local pollution and noise, they're not really sold that well. So, and that's where things like using the hybrid trains, or what they're calling bi-mode trains in New South Wales, which run on diesel outside of the electrified areas, and then electricity in the electrified areas. Though, those things are potentially a good halfway house. But I mean, you can do, there's all kinds of things that you can do where, like the light rail systems that use battery capacitors, and then they charge up at the stop. So you could do that as a fully electric mode, even over long distance. So if you have stops, and you're at a stop for 2 minutes per stop, then if you have a high enough power rated system, then you could charge up the vehicle in between. So you don't necessarily have to have hundreds of kilometers of poles and wires. That you could actually, if you have a stop every 20 kilometers or so, that you could design it so that you would have enough dwell time and charging capability that you could have electric, or you combine it with battery, or you combine it with with biodiesel. So there's no one technical solution.
It does, yeah, and I think that's true. If I would summarize our conversation, okay, it's batteries are going gangbusters and doing well. Having been in the cold for 100+ years, before the technology improved.
Yeah.
I think everything else is a bit immature still, and not quite ready for prime time. And yes, there's challenges around the rail, but as you say, are there better alternatives now that could work? And I don't know whether there's examples of what you suggested in terms of charging at stations and stuff like that. I mean, certainly that's how people are looking at certain types of buses, right, where the operating environment is challenging in the buses, and they need to have enough charging time somewhere to keep them running operationally. But yeah, it doesn't feel like it feels like we're making progress, but it's not. Certainly, I don't think anybody believes the progress is fast enough at the moment to hit us a net zero at 2050. And when you take into account that batteries alone are not going to get us there, right, then we need other technologies like sustainable aviation fuels, as an example, maturing much faster than they are. And it doesn't feel like we're pulling the right policy levers to get there either.
Yeah.
So I still feel like there is lots of virtue signaling in this space, but the policies are not going to support getting us to net zero on electrification yet.
Yeah, and going back to the freight and trucking space, you look at any major city in the world that had railway lines, there was sidings everywhere. So if the fastest way, one of the best ways to decarbonize the freight industry is to shift it back to rail. So mode shift for freight.
I'm going to disagree with you there.
Well, but
I'm going to tease this.
It's not efficient. It's not fast. It's not flexible.
I'm going to say it's also bad for carbon emissions.
Yeah.
Okay. But I'm not going to have this discussion with you now. Okay. And the reason for that is, in a few weeks' time, I will write a blog on this because I've got it drafted, ready to go as part of what. So one of the things I'm doing is I'm writing a whole bunch of blog posts at the moment on the impact, the vision for autonomous vehicles on our transport systems.
Yeah.
And I think autonomous vehicles has to make us rethink freight from completely. And I'll explain that in my blog post, and then we'll discuss it on the podcast. I don't want to discuss it now, but I think everybody I talk to, I've been saying, like, this is my hypothesis. Please, tell me where I'm going wrong. And everyone's like, sounds right, even though they don't like the answer. But we'll go with that to another point. Let's round up the discussion on electrification now.
I want to say this hypothesis because the freight electrification will worsen the last mile problem. I would say freight autonomy will worsen the last mile problem. Decarbonising freight, mode shift to rail is easier than electrifying the freight task.
Now, historically, I have always been pro transition to freight rail. But as I understand more and more about the implications for autonomous vehicles, including in the freight space, okay, I'm beginning to rethink that. So you and I need to have this conversation. I have a blog post coming up on autonomous vehicles and freight and the impact, and whether it means that we need to rethink freight rail strategy. Okay. And then once I've done the blog, we'll have the podcast, and I think it'll be a really good discussion.
Because I think it'll be like subsidizing electric cars versus electric bikes. I think we're going to have a different opinion on this one.
I think we could, but I think it's a really, as I say, I think I've always been on your side of the fence of freight rail's the answer, but increasingly I don't see how that can be the case.
The biggest problems with freight moving back to freight rail is its timeliness.
I actually think there's a whole bunch of other factors, but we will talk about that at another time. So let's put a pin in it there. Graham, as always, it was a great pleasure to talk to you. If you are a motorcycle enthusiast or you are a hydrogen advocate, please forgive Graham. We try to Graham and I take it in turns to upset different people on different podcasts. We just hope you continue. Please like, subscribe, comment, and we'd love to hear from you in the future.
Great. Thanks, Russell. Great chatting as always.
All right. Cheers, Graham.
Thanks.